In this video, we're going to work on some practice problems dealing with circles, arc measures, central angles, and things like that. So let's start with this problem. What is the measure of arc AC in the figure below? So first, we need to understand the relationship between angle B and arc AC. So let's say this is ABC. If angle B is 30, arc AC is going to be 60 degrees. You need to realize that the inscribed angle, that is angle ABC, it's 1/2 the measure of the intercepted arc, and that is arc AC. So angle ABC, that's 6x minus 2. It has to equal 1/2 of 9x plus 17. So knowing that, we can now calculate the measure of arc AC. First, we got to calculate the value of x. So I'm going to multiply both sides by 2. 1/2 times 2 is 1. And then 2 times 6x, that's 12x. 2 times negative 2 is negative 4. And so that's going to equal 9x plus 17. So I'm going to subtract both sides by 9x. And I'm going to add 4 to both sides. 12x minus 9x, that's 3x. And 17 plus 4 is 21. Now let's divide both sides by 3. 21 divided by 3 is 7. So x is equal to 7. So now we can calculate the measure of arc AC. So that's 9x plus 17. So that's going to be 9 times 7 plus 17. 9 times 7 is 63, and 63 plus 17 is 80. So arc AC is 80 degrees. Number 2, given the information below, what is the length of segment AB? So we can see that BD is perpendicular to AC. Now, anytime you draw a segment that touches the center of a circle, which is point D, to a chord, and if that segment is perpendicular to a chord, it bisects the chord into two congruent parts, which means that AB and BC are congruent. So if these two are equal to each other, then we can say that 3x minus 6 is equal to 5x minus 18. So now we just got to solve. Let's subtract both sides by 3x, and let's add 18 to both sides. Negative 6 plus 18 is 12. 5x minus 3x is 2x. Now let's divide both sides by 2. So 12 divided by 2 is 6. So x is equal to 6. So now that we know the value of x, we can calculate the length of segment AB. So AB is equal to 3x minus 6, or if we replace x with 6, it's going to be 3 times 6 minus 6. 3 times 6 is 18. 18 minus 6 is 12. So this is the answer. Now let's move on to our next problem. Calculate the distance between a chord that is 12 centimeters long and the diameter of a circle that is 20 centimeters long. So let's start with a picture. So let's say this is the chord, and this is, actually let me redraw this. Let's say this is the chord, and here we have the diameter of the circle. Now let's call this point A, B, C, and D. So CD is 12 centimeters long. We'll just say 12. AB is 20 units long. And let's say this is the center. We'll call it center E. And let's draw a line from that center to the chord. So our goal is to calculate the length of segment EF, which we can call x. Now let's make a right triangle. Actually, let's put it like this. ED represents the radius of the circle, Anytime you draw a line segment between the center of the circle and a point on a circle, that's the radius of the circle. Now, if the diameter is 20, we know that the radius is half of the diameter, so the radius is 10. Now, F has to be the midpoint of CD, since E is the center of the circle. So that means that these two are congruent. So CF is 6 and FD is 6. Now let's focus on this right triangle. By the way, anytime these two parts are congruent, then EF and CD has to be perpendicular. That's just a rule about chords and if you draw a radius of a circle. So if you draw the radius and you make it perpendicular to the chord, then these two parts have to be congruent. So EF is X, ED is 10, and FD is 6. What is the value of X? So let's use the Pythagorean theorem. C squared is A squared plus B squared. So C is the hypotenuse, which is 10. Let's say that A is 6 and B is X. 10 squared is 100 and 6 squared is 36. So 100 minus 36 is 64, and that's equal to X squared. So now let's take the square root of both sides. The square root of 64 is 8. And so that's the distance between the diameter of the circle and a chord. Now you can draw the chord and the diameter anyway, and the answer will still be the same. So for example, let's say, let me draw a better circle first. If you drew the diameter like this, then you could draw a parallel chord, and this answer will still be the same. So it doesn't matter really how you draw it. Just make sure that the way you draw it, the diameter and the chord are parallel to each other. And the distance between them is the perpendicular segment that connects the diameter and the chord. Number 4. What is the measure of angle ABC in the figure below? Now, what you need to realize is that angle B and angle D, they have the same measure. And the reason why that's the case is because they intercept the same arc. So angle B intercepts arc AC. Angle D also intercepts the same arc. So if you have two inscribed angles that share the same arc, those two inscribed angles are congruent. So let's do this one step at a time. So for example, let's say here this is A, B, and C. Let's say this is 60 degrees. The inscribed angle will be 30. Now let's focus on angle D. If it has the same arc, then the angle will also be the same, 30. So as you can see, angle B and D are congruent. So since they're congruent, we can set them equal to each other. So let's set 5x equal to x squared minus 24. Now let's move this to the other side. So we have 0 is equal to x squared minus 5x minus 24. And now we need to factor this expression. So what two numbers multiply to negative 24 but add to the middle coefficient negative 5? Well, 8 times 3 is 24. If we make it negative 8 and positive 3, these two numbers will add to negative 5. So to factor it, it's going to be x minus 8 times x plus 3. Now let's set each factor equal to 0. And so we have two possible values for x. So x can be positive 8 or negative 3. Now we can't use this answer because ABC will have a negative angle. And so that's not going to work. So we're going to use this value. So let's calculate the measure of angle ABC. So it's 5x. So it's going to be 5 times 8, which is 40 degrees. And so that's the answer for this problem. Number 5. What is the measure of angle ABC shown in the figure below? So we're looking for this angle, which we can call x. So the measure of angle ABC which is the chord-chord angle, which is formed by the intersection of two chords. It's 1/2 the measure of arc AC plus the measure of arc DE. So it's basically the average of those two. So we can say that x is 1/2 of 120 plus 70. 120 plus 70 is 190. And half of 190 is 85. So that's the measure of angle ABC, which is this angle here. Now these two angles are the same, they're vertical angles, so they both equal 85. And so that's it for this problem. Number 6, what is the measure of arc BD in the figure below? So we're given that arc AE is 90 degrees, so that's this portion here, and angle C is 15. So what's arc BD, which we'll call X? Now what we have is a secant angle. AC is a secant because it touches the circle at 2 points. Keep in mind, a tangent line touches the circle at 1 point. Now the measure of the secant angle is 1/2 the difference between the measure of arc AE and the measure of arc BD. So angle C is equal to 15. The measure of arc AE is 90, and arc BD, let's call it X. So let's calculate the value of X. So I'm going to multiply both sides by 2. Half of 2 is 1, and 2 times 15 is 30. So now what I'm going to do is subtract both sides by 90. So 30 minus 90 is negative 60, and that's equal to negative X. Now I'm going to divide both sides by negative 1. So 60 is equal to X. So that's the measure of arc BD. It's equal to 60 degrees. Number 7, what is the length of segment AE? So in this example, we have two intersecting chords, and we have the values of each segment. So how can we find AE? You need to know that the product of the segments of the two intersecting chords are equal. So AB is equal to CD, where let's say this is A, this is B, this is C, and this is D. So A is 4x plus 12, and B is 18. And so that's equal to C, which is 7x plus 1, times D, which is 16. So let's distribute 4x times 18. That's going to be 72x. And then 12 times 18, that's 216. And then we have 7x times 16, which is 112x. And then 1 times 16, which is 16. So now at this point, it's all just math. Let's subtract both sides by 72x and by 16. So 216 minus 16 is 200. And 112 minus 72 is 40. So 200 divided by 40 will give us the value of x. And so x is 5 in this example. So now that we have x, we can calculate the length of segment AE. So AE is the sum of AB and BE. So let's calculate AB first. So AB is 4x plus 12. And x is equal to 5. And 4 times 5 is 20, and 20 plus 12 is 32. So AB is 32, BE is 18, and so AE is equal to 50. And so that's the final answer for this problem. Hopefully you got it right. Number 8. If AB is equal to CD, what is the length of EG? And this is what we're looking for. Now, if the two chords are congruent, then they're equidistant from the center, and G is the center, which means that EG and FG are the same. So we could set these two equal to each other. So therefore, EG is 3x plus 7, and FG is 5x plus 1. So let's subtract both sides by 3x and by 1. 7 minus 1 is 6. 5x minus 3x is 2x. So we can see that x is 3. Now, EG, which is 3x plus 7, that's going to be 3 times 3 plus 7. Now, 3 times 3 is 9. 9 plus 7 is 16. So 16 is the length of EG. Number 9. What is the angle measure of arc AB in the figure below? So let's call this x. So how can we calculate x in this example? Well, first, let's calculate angle B. So notice that we have the measure of the intercepted arc, and the measure of the inscribed angle is half of the intercepted arc. So half of 100 is 50. So that's the value of angle B. And now we can calculate the measure of angle C. The three angles of a triangle must add to 180. So we have the measure of angle A, that's 60 degrees. Angle B is 50. And so now we can calculate the measure of angle C. 60 plus 50 is 110. And 180 minus 110 is 70 degrees. So that's the measure of angle C. So now we can calculate the measure of the intercepted arc. So the measure of arc AB is going to be twice the value of the measure of angle C. So it's 2 times 70 degrees, which is 140, and that's the value of x. So that's the final answer. It's 140 degrees. Another way in which you can get the answer is by calculating the measure of arc BC, which is twice the value of angle A. So 2 times 60 is 120. Now, arc AC plus BC plus AB, it forms a complete circle. So they have to add to 360. So therefore, x is 360 minus 120 minus 100. So 360 minus 120 is 240. And 240 minus 100 is 140. So that's another way in which you can get the same answer. So x is equal to 140 degrees. Number 10. Two circles are externally tangent to each other and lie on a common tangent BC. What is the length of segment BC in the figure below? So first, what does it mean that the two circles are externally tangent to each other? It means that they intersect at exactly one point, and that point of intersection occurs where the two circles lie outside of each other. If they were internally tangent, it would look something like this. Notice that they touch the tangent line at exactly one point, but one circle is inside of the other. So in this case, they're internally tangent. But in this example, this circle lies outside of the other one, so they're externally tangent. Now, they lie on the same tangent line, BC. BC is a common tangent to both circles. It touches each circle at one point, and so it's tangent to both. So anytime you have two circles that lie on the same tangent line, then it's a common tangent. But they don't have to intersect at the same point. Now, how can we calculate the length of segment BC? What do we need to do? So let's draw a line between point A and point D. And let's call this point point E. So notice that AB is the radius of the large circle, and the same is true for AE. DC is the radius of the small circle, so DE is also the radius of the small circle. So I'm going to redraw this figure. So here we have A, B, C, and D. So we can see that AB is 16, DC is 9. Our goal is to calculate BC, which we'll call X. Now let's turn this into a triangle. And AD is the sum of the two radius, or the two radii of the circles. So it's going to be 16 plus 9, which is 25. So that's AD. Now, if AB is 16, and let's call this new point, point F, what's AF and what's BF? We can see that BF is equal to DC. So BF is 9. So AF has to be 16 minus 9, which means this side is 7. Now let's draw the right triangle AFD. So as we said before, AF is 7, and FD is the same as BC, and so that's equal to X. And AD is 25. And this is going to be a right triangle, so now all we need to do is calculate the missing side. And anytime you have the radius of a circle drawn to a tangent line, those two are perpendicular. So they meet at right angles, and that's why we can say that this is a right angle. So now we could use the Pythagorean theorem, c squared is equal to a squared plus b squared. So c is the hypotenuse, that's 25. Let's say a is 7 and b is x. 25 squared is 625. And 7 squared is 49. Now 625 minus 49, that's 576. And so that's equal to x squared. And now we need to take the square root of both sides. So the square root of 576 is 24. And so x is equal to 24. So that's the length of segment BC. It's 24 units long. And so that's the answer for this problem. Number 11. What is the perimeter of quadrilateral ABCD? And in this problem, let's say you're also told that every segment of the quadrilateral is tangent to the circle. So with that information, go ahead and calculate the perimeter. So if every segment is tangent to the circle, what does that mean? What does that tell us? Well, first, let's identify the 4 points of tangency. Let's call this point E, F, G, and H. Let me put these letters inside of the circle. Now, we need to know that AE and AH, they're congruent. Anytime you have two tangent lines or tangent segments that extend from a common endpoint, those two tangent segments are congruent. So EB and BF, they're congruent. This is based on the two tangent theorem. DH and DG are the same, and also GC is equal to FC. Now we know that AB is equal to 12. So this is AB. And DC, that's 14. And AD is 13. Now we need to calculate the length of BC in order to determine the perimeter of quadrilateral ABCD. So how can we do that? Well, let's say that AE is X. That means AH is X because those two sides are the same. Now, if AE is equal to X, what's BE? BE is going to be the total length minus the other side. So it's 12 minus X. And BE is the same as BF, so BF is also 12 minus X. Now, if AH is X, then HD is going to be the total length minus the other side x. So HD is going to be 13 minus x. And DG is the same. Since these two are the same, it's also 13 minus x. Now to calculate GC, it's going to be the total length minus the other segment. So it's going to be 14 minus 13 minus x. And GC is the same as FC, so FC is going to be the same. It's going to be 14 minus 13 minus x. So to calculate BC, segment BC is the sum of BF and FC. So what we need to do is add those two segments. So BF is 12 minus x, and FC is 14 minus 13 minus x. So first we can combine like terms. 12 plus 14 is 26. So we have 26 minus x, and then we need to distribute the negative sign. So it's going to be negative 13 but plus x. Negative 1x plus 1x adds up to 0. And so we have 26 minus 13, which is 13. So based on these numbers, BC and AD are of the same length. So BC is 13. So to calculate the perimeter, we simply need to add up the four sides. So the perimeter of quadrilateral ABCD is going to be 13 plus 12 plus 13 plus 14. Now 12 plus 13, that's 25. And 13 plus 14 is 27. And 25 plus 27 is 52. So this is the perimeter of quadrilateral ABCD. And so that's the answer. Number 12. In the figure below, AB is 18, AC is 16, and BC is 20. And let's say you're given circle A. So A is the center of circle A, B is the center of circle B, and C is the center of circle C. What is the radius of each circle? So AB in this example is 18. And AC is 16. And BC is 20. So with this information, how can we calculate the radius of each circle? So let's label some other points. So let's say this is D, E, and F. So notice that AD and AF are congruent. They represent the radius of circle A. So let's call this X. Now, BD and BF are congruent. They represent radius B, or the radius of circle B. And also, FC is congruent to CE because that represents the radius of circle C. Now, if AD is equal to X, BD is going to be the total length minus the other side. So BD is going to be 18 minus X. And BD and BE are the same. So BE is going to be 18 minus X as well. Now, if AF is X, then FC is going to be the total length minus the other side. So it's going to be 16 minus X, which means FC is the same as EC. So EC has to be 16 minus X as well. So now let's focus on BC. Notice that the total segment BC, which is this whole thing, that has to equal BE plus EC. So BC is 20, BE, that's 18 minus X, and EC is 16 minus X. Now let's combine like terms. So 18 plus 16, that adds up to 34. Negative x minus x is negative 2x. Now let's subtract both sides by 34. And so 20 minus 34, that's negative 14. So that's equal to negative 2x. Now let's divide both sides by -2. And so -14 divided by -2 is 7. So x is equal to 7. With that, we can now find the radius, or calculate the radius of each circle. So the radius of circle A, we can see that it's equal to x, and x is 7. So that's the first answer to the problem. Now what about the radius of circle B? So that's equal to 18 minus x, and so x is 7, and 18 minus 7 is 11. So that's RB. And then RC, that's 16 minus x. So we have 16 minus 7, which is equal to 9. And so that's RC. And now we could check each answer. So the radius of circle A is 7, and for C is 9. 7 plus 9 adds up to 16. So for A and B, this is 7. The radius of circle B is 11. 7 plus 11 adds up to 18. Now for BC, the radius of circle B is 11, and for C it's 9. 9 plus 11 adds up to 20. So we know that these answers are indeed correct. Number 13, AB and BC are tangent to circle D. What is the length of segment AB? Now, whenever you have two tangent segments that extend from a common endpoint, in this case B, those two tangent segments are equal to each other. So they're congruent. So we could say that AB is equal to BC. So AB is x squared minus 1, and BC is 4x plus 4. So now we can calculate the value of x. Let's take everything from the right side and move it to the left. So we're going to have x squared minus 4x minus 1 minus 4. So 1 minus 4 is -5. So now we need to factor this quadratic expression. What two numbers multiply to -5 but add to the middle coefficient -4? So this is going to be -5 and +1. They add up to -4. So we can write the factored expression like this: x minus 5 times x plus 1. That's equal to 0. So let's set each factored expression equal to 0. So we can see that x is equal to 5 and x is -1. Now if x is -1, -1 squared minus 1 is going to be 0. And 4 times -1 plus 4, that's going to be 0. So we won't really have a tangent segment if the length is equal to 0. So therefore we're going to get rid of this answer. So we're going to go with x is equal to 5. So if x is equal to 5, what is the length of segment AB? AB is equal to x squared minus 1. And so that's going to be 5 squared minus 1. 5 times 5 is 25, and 25 minus 1 is 24. So AB is 24 units long. And the same is true for BC. It's also 24 units long. And that's it for this problem. Number 14. What is the measure of arc AXC in the figure below? So a given circle D, which means D is the center of the circle, and angle B is 40. So how can we calculate the angle measure of arc AXC? Now, angle DAB and DCB, they're right angles. So therefore, AB has to be tangent to the circle, and BC is also tangent to the circle. The radius of the circle and the tangent line, they always meet at right angles. Now, since angle B is a tangent-tangent angle, you need to know that this angle and the intercepted arc, they add up to 180. So arc AC plus angle B is equal to 180. They're supplementary. So arc AC is going to be 180 minus angle B, which is 40. So 180 minus 40 is 140. So this is the minor arc. Now we can calculate the major arc because those two arcs have to add up to 360. So arc AXC is going to be 360 minus arc AC, which is 140. And 360 minus 140 is 220. And so this is the answer. That's the measure of arc AXC. It's 220 degrees. Number 15. The radius of circle C is 15. If BC is 12 and AE is 25, what is the length of segment CE? So AE, that's 25 units. BC is 12. How can we calculate CE? So let's draw the radius of the circle from C to A. And notice that we can draw a right triangle here. So if AC is 15 and BC is 12, what's AB? So let's use the Pythagorean theorem to calculate AB. C squared is equal to A squared plus B squared. C is 15, A is 12, and let's calculate the missing side. Now 15 squared is 225. 12 squared is 144. And so 225 minus 144, that's 81. So 81 is equal to B squared. And if we take the square root of 81, we can see that B is 9. So AB is equal to 9. And notice that we can draw another radius, which is CD. And so that's 15, which means BD is also 9. So anytime you draw a segment from the center to a chord, it bisects the chord into two congruent parts. So AB and BD are the same. So now we can calculate DE. AE is the sum of AB, BD, and DE. So AE is 25, AB is 9, BD is 9, and so let's calculate DE. 9 plus 9 is 18, and 25 minus 18 is 7, so DE is equal to 7. So now we can calculate CE. So let's draw this triangle. This is C, B, and this is E. So CB is 12. BE is going to be 9 plus 7, which is 16. So now we need to calculate the hypotenuse, which I'm going to call x. So C squared is equal to A squared plus B squared. So the hypotenuse is x. Let's say that A is 12 and B is 16. So 12 squared is 144. And 16 squared is 256. 144 plus 256 is 400. And now let's take the square root of 400. So that's going to be 20. So CE, the segment that we're looking for, is 20 units long. So that's the answer. Number 16. What is the measure of angle EBC in the figure below? So we need to calculate this angle right here. And let's call it x. Now we're given the measure of arc AD. And so that's 150 degrees. And arc AE is 80 degrees. And angle C is 20. So with that information, how can we calculate the value of x? Well, let's break up this problem into two parts. So let's focus on this part. So here we have angle A, D, and C. And so angle C is a tangent secant angle. DC is tangent to the circle. AC touches the circle at 2 points. Let's call this point F. So arc AD is 150, and DF, we need to find that, and angle C is 20. Now the measure of angle C is 1/2 the difference of arc AD and arc DF. Now angle C is 20 degrees. Arc AD is 150. Now let's say DF is y. So let's multiply both sides by 2. Half of 2 is 1, and 2 times 20 is 40. So 40 is equal to 150 minus y. Now let's subtract both sides by 150. So 40 minus 150 is negative 110. So we can say that y is positive 110. And so that's the measure of arc DF. It's 110 degrees. So now that we have that answer, let's move on to the next part of the problem. Now in the second part, we're going to draw a chord angle. So this is A, E, B, D, and F. So DF, that's 110 degrees. AE, let's get rid of this stuff. AE is 80 degrees. And so let's calculate angle Z, the chord angle. So Z is going to be 1/2 the sum of the two intercepting arcs. So that's arc AE and arc DF. So it's basically the average of those two arcs. So it's going to be 80 plus 110, and that's 190. And half of 190 is 95. So Z is 95 degrees. So this is A, B, F, and this is E. So ABE is 95 degrees. Now we can calculate EBF, which is the same as EBC. So notice that these two form a linear pair. So this angle here is going to be 180 minus 95. So 180 minus 95 is 85 degrees. And so that's the measure of angle EBC. So this is 95 and this is 85. And that's the answer. 17. What is the measure of angle A, angle B, arc DF, and arc EF? So we're given that angle C is 50 degrees and arc DE is 140. So let's calculate everything else that's missing. Now we have a circle that's inscribed in a triangle. So each side of the triangle is tangent to the circle. So angle A, B, and C are tangent angles. So therefore, we know that AD and AE are congruent, BD and BF are congruent, EC is equal to FC. In addition, whenever you have a tangent angle, the angle and the intercepted arc are supplementary. So angle C and arc EF, they have to add up to 180. So to calculate arc EF, it's going to be 180 minus 50, which is 130. To calculate angle A, it's going to be 180 minus arc DE. So 180 minus 140 is 40. And then to calculate angle B, we know that the three angles of a triangle has to add up to 180. So angle B is going to be 180 minus 40 minus 30. I mean, not 30, but 50. So 180 minus 40 is 140, and 140 minus 50 is 90. So angle B is 90. Now the last part, arc DF, is going to be 180 minus 90, which is 90 as well. So keep this in mind. Anytime you have a tangent angle, the angle and the intercepted arc must be supplementary. They have to add to 180 degrees. And as you can see, 90 plus 90 is 180, 40 plus 140 is 80, 130 plus 50 is 80. And so that's it for this problem. Number 18. The circumference of circle B is 12 pi. What is the area of the shaded region? Well, B is the center of the circle, and so AB and BC represents the radius of the circle. To calculate the area of the shaded region, it's going to be the angle in degrees divided by 360 times the area of the entire circle, pi r squared. So we need to calculate the radius first. The circumference is equal to 2 pi r, and the circumference is 12 pi. So r is 12 pi divided by 2 pi. So we could cancel the pi. 12 divided by 2 is 6. So the radius is 6 units long. Now the angle of the shaded region is 100 degrees. Let's divide that by 360 and then multiply that by the area of the circle, pi r squared. And so this is going to be 100. Well, first let's cancel a 0. So this is 10 over 36. And 6 squared is 36. So we can cancel 36. So the area is 10 pi square units. Now what is the arc length of AC? So what's the distance between points A and C on the circle? To calculate the arc length, it's equal to theta over 360 times 2 pi r. So this is going to be 100 over 360 times 2 pi times 6. So we could cancel a 0, and so it's 10 over 36. 36 is 6 times 6. So I'm going to cancel a 6. And 6, I can write that as 3 times 2. And so I can cancel a 2. So the arc length is going to be 10 pi divided by 3. And so that's the distance between points A and C on a circle. So this is going to be the last problem. What is the length of segment EC in the figure below? Now we have two secants that are passing through this circle. And so we could use the secant power theorem. And so let's call this secant 1. And this is the external part of secant 1. This is the external part of secant 2. And that is secant 2. So the formula is E1 S1 is equal to E2 S2. So E1 is 8. S1 is going to be 8 plus 22, which is 30. E2, we don't know what that is, so let's call it X. S2 is going to be 8 plus X, or we could say X plus 8. So let's calculate the value of X. 8 times 30 is 240. X times X is X squared, and X times 8 is 8X. So let's take this and move it to that side. So 0 is equal to X squared plus 8X minus 240. Now, in order to factor this expression, we need two numbers that multiply to negative 240, but that add to positive 8. So let's try 10. Negative 240 divided by 10 is negative 24. If we divide it by 16, that's going to be 15. And so those two numbers differ by 1. If we divide it by 12, that's going to be 20. So these two numbers differ by 8. But we need to use negative 12 and positive 20 so that it adds up to positive 8. So to factor, it's going to be x minus 12 times x plus 20. And so we can see that x is equal to positive 12 and negative 20. Now DC can't be negative, so we can get rid of this answer. So x is 12. Now EC is the sum of ED and DC. So ED is 8. DC is X, and we know X is 12. So EC is going to be 8 plus 12, or 20. And so that's the length of segment EC. It's 20 units long.